Okay, so welcome to Web Lab Day 1. We're going to get started. So Shannon and Nick just had an amazing intro telling you about all that's going to happen this semester with making your websites. But before we actually get into doing any website coding, we first need to learn some tools that we're going to need to use in order to be able to successfully work on websites in teams. So the two tools I'll be teaching you in this lecture are Command Line and Git. Let's get started. So the plan is to first go over the command line here on the left. This is like the app symbol for command line. And then after that, we'll use command line to run some Git commands, and we'll learn about Git as well. So you'll learn about what they are, why we care about them, what they do, etc. All right, let's get started with command line. So what is it exactly? What is the command line? Well, the way I like to think about it is it's your computer secret menu. Okay, so as an analogy, let's pretend that you go to In-N-Out. And at In-N-Out, you can just look at the menu and see what they offer. You can order a double-double, you can order fries. But it turns out there's a lot more that In-N-Out can give you besides what they explicitly say on their menu. You can order animal fries, you can order an animal burger, etc. And these are options that you actually can do at In-N-Out that it does not tell you that you can do. So your computer is basically just In-N-Out in the sense that there's things that you can do on your computer that your computer does not explicitly give you a button that you can click to do that. And the way we access those things is through the terminal. So the terminal actually encompasses a lot of functionalities on your computer, including but not limited to your file explorer, your code editor, and as well as accessing Git commands. So your terminal can do all of these things and more. And in order to demo that, we'll just show how everything that you can do in your file explorer right now, everything that you can do there, you can also do in your command line, in your terminal. I'm going to use those words interchangeably. All right, so let's do a quick demo. You all should have installed Command Line or Git Bash for Windows. So if you're on Windows, go ahead and open your Git Bash. If you're on Mac or Linux, you can open up your terminal. And feel free to follow along here if you want to, but I'm just going to demo some things that your terminal can do. So if we look here at the File Explorer, I'm currently in my home directory, and I can see a list of files and folders that exist there. Similarly, in my command line, I can type pwd, and it'll tell me that I'm in my home directory. So pwd stands for print working directory. And you can see that it will tell you where you are in your file, in your folder system, kind of like how your file explorer tells you that you're currently in your home. Another thing that your file explorer can do is you can see the list of all your folders and all your documents in a certain area. We can do the same in your terminal by telling it to give that to us. So if we type ls, which basically you can think of ls as list, and we press enter, it'll list out all of those files and folders. So we can quickly see that things that you can do in your file explorer, you can also do in your command line. If I want to move into a file in my file explorer, I can double click and go into test. In your terminal, that would just be cd. So we could cd and then type the name of that folder, and it would, now if we type in pwd, print working directory, we're in our test folder. This is all to say, again, that your command line, your terminal, it's going to be a tool that you can use to do a lot of things directly, tell your computer directly what to do. There's some other things that we can do in here. we can remove files. So in my file explorer, I would right click and then delete. We can just type rm, which stands for remove, and the name of the file, and it'll disappear. We can remake files. So if we type in touch and then the name of a file, it will create it for us like that. We can make folders. So if I wanted to make a folder called new folder, I could type make dir, which stands for make directory, and that would make a folder for us, right? Just like that. So don't worry, you don't have to memorize all of those commands to start, but this is just to show that this tool exists and it'll be something that we'll need to use in order to access our computer's secret menu. All right, let's go back. So that was a quick demo of the command line. Here are some of the simpler commands that you will need to know moving forward. But to summarize on the command line, it's a tool that you can use to tell your computer to do things explicitly. And it'll come back later when we start to do practical things in WebLab. If you have any questions, definitely ask them in the questions document, or feel free to direct message a staff member on Zoom, anything like that. Because this can be confusing, especially if you have not worked with terminal before. But that's just a quick introduction. And now we're going to move on to the meat of this lecture, which is about Git. All right, so Git, what is Git? Git is a version control system. Okay, so that means that it allows groups of people to collaborate on coding projects together. And in order to understand Git, we're going to tell a story. So let's start with the story. It's story time. We have a guy, his name's Bob, right? And let's say Bob is working on a project. He's working on a file. And he's working on this file in a team. So Joan's also trying to work with Bob on the same file. So Joan tells Bob, hey, I see you have a file. Can I have access to it? I would like to edit it as well. And what Bob can do is Bob can open up Gmail or Hotmail or whatever and compose an email, attach the file, and send it over to Joan. And then Joan can open the email, download the file, make her edits, and then send it back to Bob over email. And in that way, Bob is going to receive all of Joan's edits. So Bob is going to have a file that has both his edits and Joan's edits as desired, which is great. But now, instead of working on a single document, let's instead pretend that they're working on a coding file, right? Or a coding project. And one thing you'll quickly realize in WebLab, which might be different from some of the other coding experiences you've had before, is that it tends to be the case in coding projects, especially website projects, that you're going to have lots of different files that do lots of different things. So now, instead of one file, we have a bunch of files. And Joan is going to have copies of that same set of files. And so the question is, if we use this same method of sharing files, of collaborating on the projects, what could possibly go wrong? So take a second and think about it. Definitely, if any of you want to unmute and just throw out some ideas or type them in the Zoom chat, that would be welcome as well. But what are some ideas? What do people think can go wrong?
Accidentally delete something.
Yeah, for sure. You could actually accidentally delete something. That's a good one.
Accidentally get rid of someone's access.
Yep, that's right. Yeah, this is awesome. So you guys have come up with a lot of, I don't want to say great errors because errors suck, but there's a lot of things that can go wrong. And you guys have a lot of great ideas, which is great. So let's say, oh, I think I skipped a slide. Yeah. So I think there's probably 3 main problems that I see with this schema that we want to solve. So the first one, I'm going to call it synchronization of files. And to understand that, we're going to, again, use a small story. So let's say that Bob is working and he realizes that there's a bug on line 3 in a specific file. Okay, so Bob goes ahead and fixes the bug. So far, so good. But now the web lab deadline is approaching. And so Joan scans over all the files, doesn't catch the bug, thinks it's okay, and just submits. And in the end, she submitted a buggy website because she did not synchronize with Bob and did not catch the change that he made, which would make them really sad, right? They just submitted a buggy website for their final project. So the problem here is no one knows which file is the most up-to-date in this version. So in this sort of schema. So we would want a way of knowing which file is the most up-to-date. The second problem I see is something I'll call collaboration of files. What do I mean here? We'll tell another story. So let's say in this time, Bob still catches the bug. And now when Joan is scanning, she sees something else. She sees that the formatting is pretty ugly. So she wants to fix up how the website looks. So they make their respective changes. I think someone is unmuted, but all right, we're good now. So yeah, so she's fixing the changes because she doesn't like how the website looks. And this time they do manage to realize that they have different versions. So they talk to each other and they see, oh, wait, our code is different. And their solution is, hey, you know, Joan, buddy, I know you made changes in like 50 different places, but can you just copy them over one by one, line by line, so that we can sync up and have the same version? So again, this is going to make Joan really sad because in addition to working hard on like coding the stuff and figuring out what needs to go where, now she has to arduously copy everything over, and that's no good either. And the problem is, if we realize there's 2 different versions of the same file, it's hard to know how to join them. So it'd be really nice if there was a way to automatically do that. And the third problem here with this schema is a version history. So what does that mean? Let's say Bob is coding and he wants to modify some code, and he decides to remove some lines because he suspects they might not be useful anymore. And then he saves his file, closes everything, goes to sleep. And then he comes back and he realizes, wait, I actually needed those lines because the website's not working anymore and I have no idea how to fix it. If he cannot revert back to the previous version, he's going to be really sad. He's going to have to waste a lot of time trying to figure out how to recover all of that stuff. So it would be really nice if we could go back to a working copy whenever we get into a state where we don't know what's going on and everything is just broken. So you might have been thinking, well, I know something that can solve all of these problems, right? Have you ever heard of Google Docs? And at first that seems pretty good. Google Docs does solve some of these problems. It solves synchronization and merging issues because you can have multiple people working on the same document at the same time, and all of their changes will get merged together. There's even a version history because you can click the edit history and see the previous versions of your document. So that's great. We should just use Google Docs for coding, right? Well, it turns out that you don't really want Google Docs when it comes to coding projects. And the reason is twofold. The first reason is that generally when you're coding, you're going to be working on different features. You're going to be working on separate, unrelated parts of the website. person A might be working on a button, and person B might be working on login authentication in the backend, right? So since you're working on two totally different things, you don't need to see that your partner is making progress on their feature when you're working on your own feature. It's just not relevant to what you're doing. So you don't need the live updating of Google Docs, but it turns out you actually don't want it either. And the reason is a little bit nuanced, but if any of you have ever written buggy code before, you might recall that debugging code is an absolute pain. So you can kind of imagine that debugging would be even worse when there are two people's code that could contribute to a bug that would break the entire website. So not only do you have to look through your own code, you would have to look through your partner's code as you're compiling, which is going to be an absolute pain. So we're not going to do live updating. Instead, what we want to be able to do is to work locally on our feature with the previous version as the baseline, and then building our changes on top of that. And then after we're done with our feature, sync up with our partners and combine the code together in a way that incorporates both of our features. Or we want to merge our changes. And so the solution, which you might have guessed by now, is to use something called Git. And the question you might have is, well, how does Git work? How does Git get around these issues, right? And so we'll just explain really quick how Git does what it does. And the way Git works at its core is Git tracks changes to files by doing math, by computing the difference every single time you make changes. So what does that mean? Let's go through an example. Let's say we have a document, and it starts out as version 1. It's pretty simple. And we make a change, right? So to go from version 1 to version 2, what we did was we added a line and about cats. So now we have version 2. And then to go from version 2 to version 3, we add another line like corgis. So what is going on here? From version 1 to version 2, we added this line. From version 2 to version 3, we added this line. And what Git is doing is Git is not storing this version and then this whole version and then this whole version. Instead, what Git is doing is it's storing this version 1. And then every single time you want to go to a new version, it's storing the difference between those two versions. So to go from version 1 to version 2, it's storing the difference, adding and about cats at line 3. And then from version 2 to version 3, we're adding like corgis at line 4. And so now with all the stuff that Git is storing, it can recreate version 2 or version 3 whenever you call upon it, whenever you want to access it. So if we wanted to access version 2, we would start with version 1 and include the diffs, the differences that Git stored. And now we would be able to get version 2. And then to get version 3, we would do likewise. So that's fundamentally what Git is doing. In order to understand the rest of the lecture, let's go through some terminology. Okay. So the first is a repository. Your repository is just a set of files that your Git is going to track changes on. So this is all the files involved in your project. This will basically just be your website for the sake of WebLab. A commit is then a set of changes that will move it from one version to the next version. So that's kind of like the math, right? The differences that Git is keeping track of. All packaged together, that's going to be a commit. And then finally, the log is going to be just somewhere you can access the version histories of everything. So the log contains version 1, version 2, version 3, etc. Alrighty. Now let's talk about how Git solves all of those problems that we came up with earlier. So immediately, we can see that the log that Git stores solves our version history problem. We can see that there is a log that has all of the previous versions on it, and Git will allow us to revert our project to any of those previous versions whenever we want to. So the version history problem is solved. But what about synchronization and collaboration, right? And the answer here is going to be Git servers. In this class, we will be using GitHub as a Git server. So what is a Git server exactly? You can kind of think of it as a centralized source of truth, a centralized place somewhere out there that stores the most updated version of the project, and everyone can access it. Everyone can read from it, and everyone can write to it. So how does that work? Let's say Bob is working on that same project, right? And he's going to make a change to one of the files. So he has this change file now. What he's going to do is commit those changes into a commit, right? We talked about that earlier. That's a package set of changes. And then he's going to push it to the Git server. He's going to send it to the Git server so that he updates the centralized source of truth, right? And so now the Git server is going to store Bob's updated version of that file, which is great. So now when Joan wants to start working on the project, she can request the most updated version or do a Git pull. And now her local file will be updated with all of Bob's changes. So they have the same files now, which is awesome, right? That's what we want. So just to review, a commit in Git server terms, right? A commit is a package set of changes. A push is to send commits to the Git server. It's the action of sending your commits to that centralized Git server. And a pull is the action of updating your files, of requesting the files from the Git server and updating. So that solves synchronization, but what about the merging issues from before? It's not immediately obvious how that's going to be solved. So let's see what happens. Let's say Joan makes some changes and she pushes them to the Git server. Before Bob has received Joan's updated version, he's already worked on his own set of changes. So what's he going to do? He's going to try to push them, right? But the Git server is going to say, no, you cannot push your changes. The reason is because the file that I have, the most recent file, the most updated file that I have is not the same as the one that you edited. I'm going to need you to pull first and make sure that you incorporate the changes from Joan's updated file before you can push again. So the Git server is going to deny him and tell him to pull first. So he's going to pull. And now Git runs an algorithm on Bob's computer locally that will try to merge the files. And it just does that by, remember, Git stores changes in math, right? So it's going to take Bob's set of changes, Joan's set of changes, and just try to apply both of them. And if it doesn't run into any issues, Bob will have an automatically merged file. The problem is sometimes the algorithm will fail, in which case Bob will have to go through and manually override those changes and decide what to keep and what to throw away. We're going to go through an example of that later in this lecture at the very end. So for those of you who have always been confused and sad whenever you see a Git merge, hopefully you will be less sad moving forward. Anyway, so Bob's going to merge that manually for all the parts that the algorithm does not automatically merge. And then only then can he push it back to the Git server and have everything centralized again. So yay, we've solved synchronization because we have this Git server that everyone can push and pull from. So everyone knows what the most recent version is. And we also solved collaboration because of the merging algorithm, which will work 90% of the time. And when it doesn't work, you still have a human that can manually verify what to do. Sweet. So we solved all our problems, and we know how Git works. So what can we do? Let's go ahead and try it ourselves. All right. So if everyone can open up their terminal again, we can try doing something together. What we're gonna do is we're going to create a Git repository, and we're going to initialize it, and we're going to push it to GitHub just to see what happens. All right, so if you open your terminal and you make a directory called, we'll just call it Web Lab Project. You can call it whatever you want, but if you want to follow along, you can call it Web Lab Project. So that will make a new folder called Web Lab Project, and then we're going to have to cd into it. We're going to have to change our directory to that folder that we just made. This is not your actual Web Lab project, by the way. This is just as a toy example. So this is not the folder you're actually going to be using for your Web Lab project. All right, so once we're there, we can type touch index.html. That will create a file, right, in our folder. So now we should have a folder with a file inside of it. And the last thing we're going to do is type git init. So this is an example of one of those things that we're accessing from the secret menu from our terminal. Git init, unless you have a specialized app installed, is not something that you can just click a button and do. This is a secret command. We're telling our computer exactly what we want to do with our terminal. So git init, what that does is it initializes an empty Git repository in our directory. Okay, try to follow along if you can. I'll pause a little bit on each slide so that you can copy the commands over, but don't worry if you just want to watch and follow along. That will totally work as well. Okay, so if we go ahead and type git status, we're going to see that there are no commits yet, and there's an untracked file, index.html. And that should make sense because we haven't committed our changes, right? Our changes was, what our changes were, we just created this file, right? So we haven't committed it, we have not pushed it. We haven't committed it, we have not pushed it. So it makes sense that it's not tracked by Git yet. So what we need to do is allow Git to be able to track it. In order to do that, we need to first type git add and then the name of the files that we want to add. Something that you'll see often is git add space and then just a dot. What the dot means is that it'll add everything automatically. So if you are lazy and you don't want to type index.html, you can just type git space add space dot, and that should work as well. And then after we do that, if we check our status, we'll see that, hey, we're tracking this change now, but we need to commit it, right? So the next step after we git add is we do a git commit. So that's git space commit space, and then we need to do -m space and then a commit message. What your commit message is basically a short tag, a short label that describes what you did in this commit, in this set of changes. What did you do? This will be useful for just logging purposes, right? If you want to see, oh, what did I do in this commit? Your commit message should detail that. So if you added a login button on your website, or if you added a nav bar, or you changed the font to a different font or something, those are all valid commit messages. All right, so git commit -m, and then in quotes, a commit message. So mine was OMG, I made a git commit. All right. And now if we type git status again, we'll see that there's nothing to commit. The working tree is clean. So we've committed all of our changes, right? So Git is keeping track of our commits. And in the Git log, we'll see, hey, there was a commit. And the commit message was, OMG, I made a commit. All right, so that's great. We have a local Git repository. And now we're going to initialize a Git server so that other people can collaborate on this project with us. So to do that, let's go to github.com. All of you should have GitHub accounts by now. And what we're going to do is we're going to sign in. And then on the left here, we're going to click New Repository. All right, so it's going to take us to a screen that looks like this. And in repository name, we'll just type the name of our folder, the name of our project, whatever you named it. In my case, it was WebLab project. So we're going to type that in there. And then after that's good, we are going to come down here and click create website. Or sorry, create repository. All right, and once we do that, it should take us to a page that looks something like this. So we have an empty Git server, or we have a Git server here that has an empty repository. And what we're going to need to do is we're going to push our existing local repository from the command line. Okay, so the nice thing is it tells you the commands that you need to run in order to do this. You can ignore the git branch command, actually. That's not necessary. Or you could follow it directly. Either way is fine. But the important part here is this first line, git remote add origin, and then this link. So what that basically is doing is it's linking our local repository to this Git server. So now whenever we push our changes and pull our changes, it'll be from this remote server. Okay, so let's go do that. Let's go back to our command line. We're going to type git remote add origin, and then whatever link it gave us in order to link up our local repository with the web server. And now if we do a git push, all of our local commits, all of our local changes will now be pushed to that remote server. So our packaged commit will be sent off to live at that remote server. If you do type git push, just git push, it might tell you that you have to add this flag set upstream origin master. The nice thing is that you don't have to remember that. It will always give you that warning, and it will always tell you that you need to include this flag for the very first push. Sweet. So if we go back to GitHub and we refresh the page, drum roll, we're going to see, OMG, I made a Git commit. And now instead of being some sad empty repository, we're going to have our local changes there. So nice, congrats. You guys all just created a Git repository and pushed to it. Now what we're going to do is I'm going to walk you guys through how to solve a merge conflict. So for those of you who thought you already knew everything about command line and Git, and get scared every time you see a merge conflict, now's the time to tune in and pay attention. So merge conflicts arise when you and your partner work on the same piece of code, right? And you make different changes. And the Git algorithm that's trying to combine all of your changes together is going to get confused because it's like, which one do I pick? Do I go with person A? Do I go with person B? I don't know. So usually what ends up happening is the way it happens is like one person is working on the thing, they don't push, the other person's working on the thing they haven't pushed, and then they both push at the same time. So the way that happens in this story is, let's say we go to sleep after pushing everything, right? And then we wake up the next day and we decide, hey, let's add some stuff to our index.html file. So this here is a screenshot of VS Code. That's going to be the code editor that we'll be using in this class. You should have installed it at the installation party on Saturday. If you do not have VS Code installed, please ask a question or go ahead and do it if you can do it by yourself. All right, so here I have index.html open in my code editor, and I'm just going to add some code, right? So I'm going to modify line 1 and line 2, and I'm going to write some code for my website. All righty, so we've made some code, we've saved it. If we type git status now, again, there's going to be some changes that we have not committed yet, right? Because we just made some changes, we haven't committed them. So we're going to need to add them like before. So this time I used git add dot. It will do the same thing as git add index.html. It's just shorthand. And then I do git commit. And this time my message is, I made a website. And if we type a git status now, everything should be clean. We should have committed everything. You don't need to follow along for this part. This is just to demo the merge conflict. And now when I try to push, so I typed git push, GitHub tells me your push has been rejected. You have to fetch first. Updates were rejected because the remote contains work that you do not have locally. Okay, well, let's go to the remote and see what happens. So we're going to go to our Git server on GitHub. And when I refresh, I see, hey, this guy named Akshaj came in and he made a commit at some point between when I last committed and when I last pulled and now. So kind of like in the example from the slides before, when Joan committed, when Joan pushed and Bob tried to push and got rejected, I just got rejected by the Git server because Akshaj committed before me. So what I need to do first is I need to go back and I need to git pull. So this way I'm taking all of Akshaj's changes from the Git server and updating my personal local version with that. And we're going to run into some merge conflicts this time. So as a forewarning, this will happen, but it's not going to happen all the time. It'll probably happen 10 to 20% of the time. But most of the time, you don't even have to worry about this. It'll automatically pull, and then you can just, and then you don't have to worry about it. But sometimes you're going to run into these merge conflicts. So we're going to see exactly how to address those in VS Code. So when you open up your VS Code now, you're going to see something that looks like this. There's going to be your original change up here. And then there's going to be the conflicting changes. So Akshaj and I both modified line 1 and line 2. Akshaj wrote some much nicer code than I did. And my crappy code is still up here, just chilling, right? But there's a conflict because they were both trying to modify the same line. So now locally, I see, hey, I have this version, Akshaj did this version, and then I have a few options. So the first option is I could just ignore Akshaj's changes. I could say, you know what, I think my changes are better. So I'm just going to delete all of your changes and then push it with my version. That's fine, though a little bit rude. You can also say, you know what, Akshaj, I like your version better. I'm going to get rid of my version and we're just going to keep your version. Or the way I like it the most is if you say, you know what, both of these have some useful things. We're going to combine them. All right, well, how do you combine them? That seems a little bit difficult. Well, the first thing that you need to do is recognize which part is your changes, which part is their changes. And the way you can do that, I have this extension which highlights it in some colors. I don't know if that automatically happens for the default version. But another thing that you can look at is these boxes here. So there's going to be this arrow thingy with a head, and then there's going to be your local changes underneath that. And then there's going to be this line of equal signs. So everything between this head and this set of equal signs is going to be what you did locally. And then underneath the equal signs down to the arrows and then this string here, that's the git commit ID. Everything between this equal signs and these arrows, that's going to be the other people's work, the other people's changes. So that's how you tell what is what. So that's my commit. This is Akshaj's commit from the Git server. And the way I'm going to modify it this time is I'm going to say, you know what? I think the content that I put is useful. I'm going to incorporate it into Akshaj's framework. So what I'm going to do is I'm going to move my set of changes into the body of Akshaj's text. So I went from here. I copied my stuff. I deleted it, and then I pasted it into the body of the website. So that would be right here at between line 10 and 11. And now I'm happy with this version of the website. So then I can go back to my terminal, my command line, and I can recommit those changes. So I'll add it again, and then I'll do a commit and then a push. And now Git, if I go to the Git server and I refresh, we're going to see that it was correctly merged. That was my commit message. And it now has an updated version that has both of our changes. Okay, so that's the gist of how you solve merge conflicts. If you ever run into those, which you will, definitely ask us for help. We're more than happy to do that. And we have one last thing to do before we go on lunch break. So what is that? We need to get the workshop. So throughout this web lab class, we will be interacting with Catbook, the website that we'll be building together. And throughout that, we'll be teaching you a bunch of different concepts in web programming, such as HTML, CSS, JavaScript, etc. But in order to follow along, we need to have a version of this Git repository. So if you go to this website here, weblab.to/catbook, it'll take you to the website. And what we're going to need to do is we're going to click this green code button here and copy the HTTPS string, the web URL. And then what we're going to do is we're going to go to our terminal. And what we're going to need to do is type git clone and then the link. Git clone and then the link. And if we do that, it will clone Catbook React into a local folder. So now when we want to work with the Catbook React code, we can look in it and see, hey, look, it has a bunch of different files for everything that's going to happen in this class. So in our next workshop in the afternoon, we're going to be working with this repository. So make sure you have it downloaded. If you can't figure it out, ask someone for help. Okay, let's take a look at that. So if we cd into our Catbook React folder and we open it up, we can see that there's a bunch of files in the Catbook React website available to us. We'll get to play around with all of this later. One thing real quick that I'll say is that it's going to be a tough time coding on one screen while watching the Zoom. Like if you're trying to follow along with the Zoom on one half of the screen and your VS Code on the other half of the screen, that's going to be a tough thing to do. So we put a little bit of thought and effort into trying to, you should put a little bit of thought and effort into arranging your screen optimally to do this. One thing that I found generally works for me is if I have my VS Code on the left here, you can do some tricks like making this smaller, dragging this over, and then having my Zoom stuff on the right over here. And then having the terminal hanging out down here so that I can click on it and run commands if I need to. And then finally having a web browser up on the side, maybe somewhere down here, so that you can look at the website and see what's up over here. Alrighty. So that's going to do it for the presentation today. As a recap, we learned what terminal is, what command line is, and we learned what Git is. We learned how to use some Git commands through the command line. And that's going to help us a lot with collaborating on our websites moving forward. We're going to have a bunch of these commands, a bunch of Git commands, command line commands. All of that is summarized here, as well as in a couple of cheat sheets that we've linked. So if you ever forget anything, you need some refreshers, definitely check those out because there's no expectation that you memorize all of these starting on day one, but you will need to get familiar with them throughout the class.